Alright, I'm going to try to explain and break down this circuit that has the motion sensed lighting controller that I made not too long ago. We'll start with this diagram. It has a step-up converter. That step-up converter is using a micro USB connection. It takes 5 volts for a micro USB and steps that up to, I believe it was 14 volts. Let's look at that. Okay, this is the step-up converter that I used. Got 5 of them for about $6. It takes micro USB in and outputs whatever voltage higher than 5 volts. And how you adjust that, there's a potentiometer here. You'll turn that and adjust the output. And what I chose, I believe, was 14 volts for the battery management system that I was using. I would also recommend, after making the adjustment, to put some type of glue or super glue on that potentiometer so it doesn't accidentally turn later on. Alright. The next thing in the circuit is a battery management system that's here, and let's look at that. Okay, this is the battery management system I chose. It needs a minimum of 3 batteries. The more you add like this in parallel, the higher capacity you get. But 3 batteries into this BMS will produce about 12 volts. It's protecting those batteries from under voltage, over voltage. The step-up converter is connected to these same points as the output, and when you connect micro USB into that step-up converter and output, think it was 14 volts, it'll start charging these 3 batteries or how many ever you have. Let's look at the specs on it. So charging voltage, this is where I chose the 14 volts, but I think anything in between that is fine. There's a diagram in over here that shows you how to hook up each battery to this board. If you were to add 3 more, then they will just be parallel to these 3 that are currently here. That will increase capacity. Those 2 in the middle are outputs and also your input for charging the 3 batteries. After that, from the body BMS, I was going to say body control module, the BMS, it goes directly into the motion sensor. It accepts 12 volts, and also the positive goes directly to whatever you're controlling, if it's lights or whatever 12 volt device. The positive just goes directly to it, and what's controlling on and off is going to be the ground side is switching based on the output of that motion sensor, which is controlling a transistor we'll talk about later. Let's look at this motion sensor. The motion sensor I bought some time ago. Let me see if I can pull up some information on it. So this website here, it goes into detail as far as what the motion sensor is doing, and also the pinout on it. There is a protection diode on the board. Let me try to find another picture. Okay, this is a good one. So there's a protection diode on the board where the 3 pins are, and the pin closest to it is your input, and it accepts 5 to 12 volts. The middle pin is your output, which is going to this wire here, going to your transistor. So here's pin number 1, 2, and 3 is ground. That ground is going directly to the BMS. Okay, let's go back. There's two adjustments for it. It's time delay. Time delay is closer to the diode we were talking about earlier. And there's a sensitivity potentiometer also that you can adjust on it. There's a jumper on this side, and what that does is based on the position of that jumper, you can move the delay, not delay, but you'll see on the board itself there's a H and a L. Let's look at this. You can see an H here. You can see an H here and an L there. The H means that once motion is sensed and the motion is no longer sensed, and if it before the time delay happens, if it senses it again, it resets the timer. If it's on L, if it sees motion and it will ignore it seeing motion within this time delay. So let's say you walk past the motion sensor, the light turns on, and then you walk back the other way, but the time delay says it's going to be on for 1 minute. The light is on for 1 minute, and in 30 seconds you walk by it again. It's going to ignore that movement past the motion sensor and shut off in 1 minute. Then if you, after that 1 minute, if you move past the motion sensor again, it's going to turn back on for a minute. Whereas H, if you walk past it, it will turn on and start counting down that 1 minute. Then if you walk past it again, it will reset that 1 minute and start from the beginning and start counting 1 minute from that point. So I think it would be best for it to be moved to H, was like the common thing to do. So there's our 3 pins. Looks like this one accepts all the way to 24 volts. Let's see what something like this costs. I usually use eBay for these type of things, and Amazon also has it, and I'm sure they provide faster shipping. Let's take a look. So this one you can get it basically tomorrow. There's 15 of them, $20. Seems kind of high. Okay, let's try eBay. And I'm going to choose US only. I usually like to buy these type of things in a pretty good quantity, just in case I need it in another future project. I have it on hand, so I would probably buy about 10 of these, and here's one, 10 of them for $12, coming from California. Alright, let's look at the circuit again. So those are our 3 connections to the motion sensor. So 12 volts in, ground, both going directly to the BMS. The 2 wires in the middle of the BMS that we talked about earlier, and then the middle one is going to output to a transistor. Let's look at this transistor. Okay, so this is the internals of this transistor. It's called the TIP 120. It is a NPN, which means it switches the ground. So pin number 3, let's look at the circuit. is going directly to ground, to the BMS. Number 2, the middle pin, is going to be the source, or the what you're trying to control. And if you look at number 2 here, that's going directly to the light. Then the first pin is the base, and when it sees a small voltage here on number 1, the transistor starts conducting from number 3 to number 2, because this motion sensor outputs 3.3 volts. Is a very small voltage, so that's what this transistor is doing, is acting like a relay basically, and it's switching on this transistor, which allows it to conduct from ground into this ground and turn on the light. This transistor is what I had on hand, but if I had the items already, I would probably use, a better thing to use would be a MOSFET. And the type of MOSFET I would want is a logic level MOSFET. So let's look at that. Logic level MOSFET. Okay, this is IRL. There's also a IRF, and on the L means that it's a logic level MOSFET. I looked at this earlier. This would be the best thing to use for this type of circuit, because it kicks on at a very low voltage. Let's look at the data sheet for this, and I'll show you what I'm looking for when choosing a MOSFET for this. Okay, here we go. VGS threshold. So gate threshold voltage 1 to 2. So that's the voltage it starts conducting. So in the pinout for this, it doesn't show it here. The pinout for this is the exact same as that TIP 120. Number 1 is gate. Number 2 is the drain, which is what you're trying to control. Number 3 is the source, which is going directly to ground. So when gate sees a small voltage, which was, let me see, between 1 to 2 volts, it starts conducting between source and drain. So number 3 to 2. So that TIP 120, if you were to remove it from a circuit and drop this in, it would work the same way. Let's look at the circuit. So I think that's it. That's everything. Again, if I were to remake this, I would use a MOSFET. Let's see how much that was. So 10 of those MOSFETs were $6.63 plus $4.30 shipped from Illinois. That's it. That's everything in the circuit. And again, you don't have to use a light. You can use whatever you're trying to turn on, based on motion. I think that's it. All right. Thank you. I'll leave some links in the comments section that links to all these items and some additional information. All right. Thank you.